Janardanan Venkat. He works as General Manager of Reddington 3D with over 25 years of experience in technology industry. He leads his team to drive sustainable growth of the 3D printing business in India. Mr. Janardan, he joined Reddington in 2011 for managing the growth strategy of 3D printing solutions and applications across different industry segments when 3D printing industry was taking shape in Indian market. He redefined the strategy of additive manufacturing applications for short batch manufacturing in the automotive OEM supplier, medical device, and other industries. He has extensive experience in the additive manufacturing industry, serving as an expert speaker at multiple industry forums across India. So, I welcome you, Mr. Janardan Venkat. And I hope this session is going to be a very interesting and informative one. Sir, we can start now. We can start the session now, please.
Thank you, sir. Thank you for the introduction, and good afternoon to all of you. My name is Janardanan. I work for Reddington as the general manager, taking care of the nationwide 3D business, 3D printing business. So I joined Reddington when we started this 3D printer as a business unit. So if you look at Reddington, we carry almost 200 plus solutions, and we are the distributors for multiple ranges. So when we ventured into the 3D printing business, I joined the team, and along with me, I have Vinod also, who has joined from Delhi, and he is handling VSSCT and interacting with all their team members in VSSCT. So he also is in the part of the meeting. So what we normally, as a Reddington, as a company, what we do is basically we are distributors of quite a number of products. In addition to that, we also have the complete range of 3D printers installed in our facility, and we do some service jobs using that also. So it's part on demand services. So I'll just come to it later. So I'm not taking too much of time for the introduction. So what we are going to discuss today is the relevance of 3D printing and why 3D printing is becoming more popular and becoming a buzzword today in the market. Now, if you look at the industrial revolution, what we have done is from a handcrafted manufacturing, we have grown to a level where computers and automations are already getting implemented. And the next phase of industrial revolution, termed as Industry 4, is on the way now, where the cyber physical system, that is basically what we are speaking about, is basically integrating machine with human thinking, or analyzing the data, past records, and take decisions by itself. Some sort of decision making also is getting incorporated, and we are relying on machines for that also today. So the Industry 4 is going to focus on artificial intelligence for taking decisions. It is also going to focus on IoTs, or Internet of Things, basically for integrating physical items with the complete network. And we have a lot of data, which most of the time what we do is we will remember few, we will refer few, and we take decisions depending on the data. So we are authorizing or deputing computers to take some data analytics and take decisions using artificial intelligence. So that is something which is really on the way. And deploying more of robotics applications and automating the whole thing. That is becoming the focus of Industry 4, along with the 3D printing, because 3D printing is basically a digital manufacturing tool, where this really gets into or fits into this scheme of things in Industry 4. So 3D printing is becoming more and more popular, mainly because that is termed as one of the key manufacturing mode of manufacturing. If you look at so 3D printing is becoming is getting popular as a mode of manufacturing today. So we spoke about injection molding. We have CNC machining. So these are all today become the norms of manufacturing. So what we are anticipating is 3D printing is going to take a center stage in the manufacturing process. So no way we can eliminate any of this manufacturing process, whether injection molding is going to coexist with 3D printing, or 3D printing is going to coexist with the CNC machining. It is going to coexist with your casting. So all these manufacturing modes will be available, and people started realizing the value of 3D printing and recognizing 3D printing as another alternate mode of manufacturing today. So that is the growth we are able to achieve, and how we achieved it. That is something which we are going to discuss about it. So the primary objective of all this is basically to really achieve higher capital efficiency. So if I want to save money for the company or increase the profitability of my business, the first thing is what I need is I need rapid innovations and bring the products much more faster into the market. Mainly because the market is becoming more and more competitive. It is becoming much more demanding. People are also expecting new products to come into the market at an earlier date, so that they will be able to get it. So if you look at the mobile market, if you look at the speed at which new models are coming up from different companies and how competitive it is becoming, that set the trends for the market demand today. So market is expecting that kind of a turnaround of new products into the market. Second way of achieving capital efficiency is basically shorter delivery time. When I start a project, earlier days, if you look at the time of ambassadors or all these cars, there is a design time which is much longer. And after completing all the design, they will manufacture the tools which is required for mass manufacturing. Then they launch the product, and the product and the next batch of product or next modification of the variant of the product comes after a very long time, mainly because it takes a longer time for really setting up the plant, getting to the manufacturing mode, and bring the product outside the market. So I think we can't afford to take that much of time today to deliver or design and deliver a new product or new series of equipments. Third is managing the inventory. We cannot pile up our inventory, and we want to, at one point of time, we may have to move on to production on demand or the on-demand manufacturing. That is a concept which is growing now. And the performance has to improve all through the whole thing. If you are having a better performance on this and efficiency in your production site system and on the equipment, that is going to be the worthwhile. So today, if you look at, people are moving away from standardization. If you look at the time of ambassadors and all this kind of stuff, we have a standard model, and that model is getting sold in the market. Today, people are speaking about customization and personalization. So more focus is getting shifted into customization and personalization. Second thing is basically heavy devices into ergonomic and lightweight devices. If you look at the evolution of electric cars or something of that kind, what we are looking at is basically making it as lightweight as possible, so that we will have the maximum efficiency achieved out of the system. Third is the manufacturing constraints. As to when you are doing a design using an injection molding or a CNC or any other alternate manufacturing, what happens is basically you have to design the product or the way you manufacture for the manufacturability of this. So for example, if you look at injection molding, we have to really put a lot of effort in getting the right flow patterns while we are doing the molding, or draft angles has to be defined in such a way that we will get the maximum quality for the product. So there are design constraints with you. Or if you are looking at a CNC machining, what happens is we need to think about which machine is going to manufacture this, whether it is a 5-axis machine or a 3-axis machine, and my design has to be in line with that manufacturability of that part. So all these constraints has to be removed at one point of time. We need to have a free-form design. So that is something which people are looking at today, because I cannot work with constraints. I want to work freely and do designs freely. So the market today is transforming into these stages, and that is where the 3D printing is going to add a lot of value for you in the whole scheme of things. Now, if you look back, these 3D printers are available in the market for almost 25, 30 years. And if you look at these 3D printers, commonly it is also called as rapid prototyping, and it is also called as additive manufacturing. So all these terms leads to one thing, basically a layer by layer creation of your 3D part. So that is what exactly is what about the 3D printing or additive manufacturing or rapid prototyping. So if you look at a CNC machine, what we are doing, we are actually taking a block of wood, we are going to subtract the parts which is areas where we don't need it, and create a geometry out of that box. Box. Here, what we are doing is we have a 3D model, and if you slice an apple and really rejoin them like this thing, what is the geometry we get is an apple, right? Similar way, what we are doing is we are taking a 3D model, digital 3D model, slicing it layer by layer, and constructing layer by layer, one over the other, and creating a 3D model out of it. That is the way the 3D printers works. So it is a layer by layer construction from the bottom or from the top, where the geometry is achieved by adding layer over the layer to get you the 3D Z axis direction. So that is what is called as additive manufacturing. Now, if you look at the history, this is available from 1986 when Charles Chunk Hull has invented this SLA technology, and he commercialized it in 3 years' time, and he started a company called 3D Systems. Then came the FDM, the most commonly used the 3D printers, the fused deposition modeling 3D printers, which was it came into 1889, and after that, technology over technology has started coming in, and the latest technology which is available right now is launched by HP in 2017. That is basically we call as the multi-jet fusion technology. So if you look at, we have seen a lot of new technologies coming into the market. The basic nature is layer by layer construction, and it has got its own characteristics and different way of thinking. So if you look a little detail into the industrial 3D printing technologies available in the market, we have the FDMs, we have the polyjet, that is basically jetting technology after this inkjet technology has come in 2D printing. A similar way, instead of so if you look at FDM, what they do is a fused filament is getting deposited like a using a tool path. Something like in CNC machine, a tool will remove the material from a block of material, whether it is an aluminum or steel or whether it is plastic. It removes this thing. So same tool path is getting followed, but only thing is instead of removing the material, it just keep depositing this material like when you create an jalebi or something like that. What you're doing, you're just creating a layer over the layer and creating the jalebi. Similar way, the FDM extrudes the material across wherever it is the material deposition has to be happen. It follows a tool path and deposits it. That is the technology called fused deposition modeling. When you look into polyjet, what it does is basically like a 2D printer, inkjet 2D printer. So in the inkjet 2D printer, what happens is you will be jetting the inks wherever it is required, whether the text or image is required. It jets the ink at that location, the specific color, and creates the um, uh, drawing or whatever, the text or whatever it is in the sheet of paper. In this case, what it does is it jets the plastic material, and there will be a lighting source which goes across the platform. And what it does is basically it photocures. It is basically a photopolymer is getting jetted, and the UV light which passes through that will polymerize the material, and the polymerization happens, and it will become a solid material. And likewise, layer by layer, it creates a 3D model. MJP and polyjet is of similar technology. Only thing is from two different terms from two different manufacturers. Then we have the SLA technology. SLA technology is something like you have a tank of photopolymer. A UV laser beam goes across and selects the point where the polymerization has to happen, and gives the last mile energy or the light source at the specific point to create the part across layer by layer. So that is the stereo lithography technology, which is the first technology which is invented in 3D printing. Then we have the CJPs and SLAs basically in the powder-based technology, where a layer of powder is getting put, and in SLS what it does is a laser beam goes and sinters or welding happens, or it melts that area, and layer by layer powder is getting sprayed, and laser beam goes and sinters it. So it is basically as the selective laser sintering methodology. So it is a powder-based system on a powder bed. Whichever area we need to sinter, we just laser beam goes and sinters it and uses that. The same technology they ported in metal also. Instead of a plastic powder, they started using metal powder for the sintering, and at high temperatures, the metal parts are getting generated using the DMP technology, that is direct metal printing technology. So these are the technologies available today in the market when you look at an industrial 3D printing use. So what HP has done is HP came up with a combination of these technologies in 2017. When they launched, they leveraged their expertise in inkjet technology. They use the powder-based technology for just getting the powder. So instead of a laser beam in this case, what HP does is HP uses the inkjet technology to put something called a fusing and detailing agent, and wherever the fusing agent is getting deposited, that area melts and that will become solid. So they have brought in a hybrid technology, multi-jet fusion technology, which is available today and which is the latest of the 3D printing technologies available in the market. So if you look at a closer look at the 3D printing of multi-jet fusion, which is the latest technology, you can see a layer of powder is getting sprayed now. After that, a print head moves across, jets the fusing agents and detailing agents, and a last mile energy is given by the print head for fusing the areas where the fusing agent has been deposited. And the detailing agent's functionality is to avoid dissipation of the heat beyond that point so that the powder surrounding area will not get affected. So what they have done is basically they used the powder-based technology and they used the inkjet technology to generate this new system called multi-jet fusion technology. So advantage of this system is basically it is the fastest of the technology because it needs to spray a layer of powder, and across one movement of the print head, you will have the parts generated for that. So what is basically does is basically it is we call as a page away technology in printing. Then we don't need a support structure because if you look at polyjet or if you look at SLA or any other technologies, FDMs, it needs a support structure because the spraying or deposition of material cannot happen in the air. Here in this case, what it does is since the powder bed acts as a support, we don't need a support material. And unlike the SLS system, we don't need a laser since we are not using any laser or high power equipment. We don't need inert gases because when the laser goes and cinders the powder, there is a chance of explosion. So we have to fill that complete chamber with inert gases like nitrogen or argon. That is totally avoided here. So this technology has become a very simple technology and most suitable technology for increasing the speed of production for you. So that is one of the reasons why the digital manufacturing has really picked up in the market since the emergence of this technology into the system. Now, if you look at the machine, this HP 3D printer gives you very strong, durable parts, which is basically as good as for your injection molded parts. So what you are looking at is earlier, if you look at SLS technology, if you are looking at polyjet technology, it is not really using a thermoplastic. It uses thermoset plastics. And the plastics are not that strong, which can be used as an end-use part. For example, if I want to print a part and use it in a car as an interior or in an aircraft as an interior part, or if I want to use it for packaging, or if you want to really use it for the end function, that same part goes to as an end-use part in the equipment. That may not be possible with the polyjet or SLA technologies because these are all epoxy plastics and these are not real thermoplastics which you use it for engineering manufacturing. So this technology gives you really strong durable parts which is suitable for end-use parts, and also it also gives you isotropic this technology also gives you isotropic parts. What I mean is basically in the X, Y and Z direction, the strength of the part is going to be same. If you look at FDMs or if you look at other 3D printing technologies, since it is creating layer by layer and there is a time gap between the layering, what happens is the bonding between the layers will not be as good as your injection molded part. But this technology, it is quite comparable with the injection molded parts because along Z direction also we will be able to achieve the same strength. That is why it is called as isotropic parts. Now, this equipment also has been designed for a high-speed printing and a high-volume printing. Basically, they have done the design of the equipment as 3 different components, and these 3 components really makes the system use 24/7 uninterrupted. For example, the printer's job is only printing. We have a separate unit called processing station which handles the powder, and the building unit is the interface between the processing station and build units and the printer. So what happens is if I have multiple build units, I don't have to stop the machine. Once the one print is out, I can take out the build unit, insert the second build unit, and start printing the next job. So uninterrupted, I will be able to generate the output from the printer directly. So that is one of the reasons why the throughput is very high on these machines, and it is also the most suitable product in terms of your production environment. Now they also have a color printer, the 580 series, and which gives you a true color picture. So HP leverage their technology in terms of getting the color combinations right on the parts, and the millions of colors can be generated by mixing CMYK inks. And the same technology what they use for the 2D printing, they have deployed here also with the color agents, and you will be able to generate color parts out of this machine. So if you look at if the 3D printing, there is a revolution happening today where we are getting strong induced parts out of this printer. We can also generate true color parts from this, and these parts can be used as your complete 3D manufacturing printer. So why we are able to really analyze these competitive technologies and why we are able to really speak more about the 3D printers is mainly because as a team in Redington, we have the complete range of 3D printing solutions available in our office. So for example, if you look at, I have three printers from HP, all the three series of printers available from HP on sales. All the 3D printers are available where we are using it for production in our facility. And we also have an SLA machine, we have an SLS machine, we have a few FDM machine, we have a polyjet machine, we have a multijet. So whatever technology we speak about, except for the metal 3D printers, I have the complete range of 2D printers available. 3D printers available in our facility, where we are quite experienced in operating that, seeing the benefits of it, and we are also interface with the customers to see the merits of each and every type of 3D printers. So that is one of the reason why we can authentically say this printer can do this job, this printer cannot do this job. So we are able to tell you mainly because for over a decade we are using these machines, and we are using HP machine for the last 3 years. Along with that, we also have the vacuum casting, the conventional rapid prototyping tool, vacuum casting, and we also have the CNC machining. So we have a setup where we operate a production environment in our office, and we are able to speak more about all the technologies mainly because of our experience in this all the series of 3D printers. Now, from our experience, what we could see in the market is basically conventionally in the last 25 years, 30 years, where the 3D printers are in the market. Most of the 3D printers today, the customers has bought these 3D printers only for prototyping job, mainly because the speed and throughput is not good enough for their production jobs. Second is the part quality and the material doesn't suit, because as I told you, polyjets or SLAs or all these 3D printing technologies will give you prototyping parts, basically only for look and feel and not as functional parts. And the value proposition, in the sense that the production cost of most of these technologies are much higher than your normal production cost. So that is one of the reasons why we are not able to really port these machines for a manufacturing environment. And these machines for the last 20-25 years are basically lying as a prototyping in the prototyping market. Today, what we are speaking about with HP is basically taking a drastic change the way we approach the market, and we are speaking about digital manufacturing using these new technologies. So for example, I'm just telling you at the speed and throughput. HP with the modular design, the speed at which it manufactures the part, in 10 hours, it is able to manufacture complete a printer of the full bucket. Whereas as the number of parts increases, it will not impact the time of printing. Likewise, rather than going to each and every point and sintering it like an SLS machine, here one layer is getting completed in a split of a second. So what happens is the speed at which the construction happens is much more faster compared to any other technologies, because it is a page-wide printing, not a point-to-point printing. Similarly, the design of the machine, everything is enabling the HP as a production machine. Now, what the market is also looking at is, if I want to make, say for example, I'm launching a new product, I want to understand how the market is going to respond for that product. I don't want to commit myself into crores of investment for the tooling. So what people are thinking about is, let me launch 500, 1,000, 2,000 parts now in the market. Let us see how the market responds. In the meantime, if I want to do some improvisation on the design, my designers can also do the improvisation as per the market demand. And the next 3 years, or next 6 months, 8 months down the line, I can invest on the tooling and enhance my production once the market demands increases for my product. So that is something which the market is really thinking about now, because if I want to launch a product after tooling, I have to invest crores and crores of rupees. But if I can avoid the tooling part of it and do a soft launch with these designs 3D printed, that will end up much more economical for me. So if it is successful, I can always switch over to the same design can be ported after making some tools. If it's not a successful model, I can supply the spare part, 3D printed spare parts in the market. I can change the design and relaunch the product with a new design, and as per the success, I will be able to generate tools accordingly. So likewise, with a lower risk, with a lower investment, if I am able to launch a product, that is the best way of doing it. Similarly, personalization or mass customization. I don't want the same product to be in crores or millions products launched into the market. I want personalized products with a personal imprint onto my product, something of that kind. For example, tomorrow, if you look at, I can go for a shoe, which might be a standard shoe which is available in the market. But if I scan my leg in my Bata shop or a Metro shop, scan my leg, and the next day I will get a sole fitted into the shoe, which is really as per my geometry of my leg. That is the way people are speaking about today. So I can have a standard design for this thing, everything is fine, but my sole has to be personalized for me. So one of the components in that shoe has to be manufactured personalized. And that is where the 3D printers is going to happen. So as I told you, 3D printer is not going to really eliminate the other modes of manufacturing. It is going to complement for personalization of certain areas or certain components in your design. So likewise, we are going to start, or we are really getting into the market, educating customers what are the other benefits you can get out of 3D printers, how we can port certain components of your design onto 3D printers, where you will get the benefits of personalization, or complex designs can be made complex. I can integrate multiple parts into as a single assembly and print it. So a lot of benefits we will be able to achieve out of 3D printers. And this is what the market is looking at. And this is what we are delivering today into the market under the banner of digital manufacturing. Now, to get a little detail into this, the applications which we can focus on is basically personalization, performance optimization. I have launched a product. I need to relaunch that product with some improvisation or performance optimization. I can do that using 3D printers. Or if I want to really do a generative design using lattice structures and optimization of the design using the software tools, I can do that and get it printed, which may not be possible on the conventional manufacturing. If I want to have only a few thousands of parts to be manufactured in a year, for example, if you look at tractor manufacturing, there are tractors available in the market which may sell at 30,000, 40,000 tractors in a year. Few variants of it, for example, just like a few demands for an air-conditioned chamber for my tractor. So if I want to incorporate an air-conditioned chamber, it may sell only 2,000, 3,000 a year. So the air conditioned part can be digitally manufactured rather than getting into the tooling, where the HVAC can be designed, it can be 3D printed, and on demand, it can get manufactured and fitted onto the vehicle. As the volume picks up, I can always go for the tooling. So likewise, if I want to have variants, or if I want improvised designs to launch into the market, I don't have to get into the conventional way of manufacturing by investing on tools. I can always go with a 3D printed part for a certain extent or for a certain volume, and then switch over to mass manufacturing mode whenever it is required. So likewise, the value addition, what we are going to give in the industry is basically speaking about low volume production, about complex designs and geometry, integrated designs and geometry, and creating a value proposition for that kind of components. I am not speaking about a part which is getting manufactured in millions, where the tooling will be the most economical way of manufacturing. Now, if I want to really get into a transition of digital manufacturing, as I told you, each and every component of my product cannot be manufactured in 3D printing because it may not be viable for you to do that. So what we are speaking about is basically you have to have the right technology as per your demand to manufacture, depending upon the material, depending upon the speed at which you want it, the volume of parts or the number of parts you have to manufacture in a year. According to that, you may have to really choose a technology for that. Second most important thing is, don't try to put everything into 3D printing. Whatever you feel commercially viable, design modifications which is required for that. So depending upon the application, depending upon the design, you can choose which manufacturing mode will be more economical for you. And third is basically, normally in the prototyping market, I will design some products or some components or child parts basically for manufacturing in injection molding. And then what I will do, since soft tooling or mold and production might be long time, it will be a long duration job, or this might be more expensive. What I will do, I will share the design to the market and ask them for to get a 3D printed part. And when I get a 3D printed part of the design, which is been designed for CNC machining or for injection molding, what happens? The design is done for something else, and what I am doing is the manufacturing mode is something else. So the economical viability will not be, or proposition will not, value proposition will not be right. So what you have to do is, if I decide that these are the components which I am going to do design using 3D printing, then why can't you design it for 3D printing? Why you want to design it for alternate manufacturing and then print it? So spend some time, modify your design for 3D printing as per the parameters of 3D printers, and then start producing that parts using 3D printer. Then you'll be able to establish the value proposition, mainly because of your design changes, probably a material saving, probably some sort of part consolidation. All these things is possible when you start designing it for 3D printing. So these are the three key areas which I am going to discuss in the coming slides. So what we are speaking about is choosing the right application. When you choose the right application, what you're designing, is it basically a functional prototype where you want to do the testing? Probably we have done some projects in the market where almost 300 cars were running with all the inside lock assemblies and outside lock assemblies 3D printed, because they wanted to do a pilot launch or test run of these vehicles across the environment and see the performance of the engines or performance of certain components. So what they have done is, they have done a new platform of design in a car, and they have opted 3D printed parts into that wherever they can fit into that, so that they don't have to go for soft tooling to reduce the cost of this pilot, this kind of alpha beta launch parts, or basically we call as development parts. Similarly, so for example, if I want to personalize certain components in my car, or I have a complex geometry for a better circulation in my car as per my demand. So I want to have certain numbers, 1,000 numbers, 2,000 numbers, 5,000 numbers, 10,000 numbers to be printed. So I can choose that parts and port it onto this. Or for example, a company like Ford or Toyota, where Endeavors or these kind of vehicles are not sold in millions or something of that kind. What Endeavor is getting manufactured in a day might be around 20 Endeavors in a day, or probably 30 Endeavors in a day, where I don't have to import that parts, because it will not be viable for me to do the tooling and the manufacturing of that low volume parts, whatever demand in the industry. So what they do, they start importing the parts from a global market. They can avoid that, and they can have the design printed and used it for demand. So when the volume of production is low, or for example in the tractor industry, as I said, or it might be a SPM machine, or it might be a packaging machine, where the volume of production is going to be low, or it is basically some sort of a customized production. In that case, we can always start printing rather than going for a tooled manufacturing. Similarly, the manufacturing tools, that is something which is the key applications which you're focusing on. Mainly because if you walk across the platform, if you walk across a production line, you can see people lifting heavy assembly tools, or probably checking fixtures. They have to lift aluminum tools, which will be in 10 kilo, 15 kilo aluminum tools number of times in a day. Do you really need that kind of heavyweight aluminum tools? Because this aluminum, normally the tooling industry, they do the machining, and the designing will be in such a way that I want to reduce the machining time so that minimum material get removed. So it is going to be heavy. So when you are going for additive manufacturing, what I are doing is you are minimizing the material. I can make it lightweight. So the fatigue which the person who does the job in the field or in the production line, the fatigue will be too less when you are providing with a lightweight tool. So most of these tools which you see in the production line is over designed. Can we have a scope of removing that or replacing that with a plastic made 3D printed fixture, or a assembly tool, or whatever it is, jigsaw fixtures? So that is another market which really opens out for 3D printing as a digital manufacturing mode. So these are the areas where we are focusing on, where we feel that with the emergence of HP 3D printers, we will be able to focus, and we will to create really a good impression in all industries using these applications. So for example, if you look at, you can see the number of parts which is getting made over there. Say for example, on the right side, It is basically a truck IP, in the internal panel, where they wanted to have launched 10, 15, 20 trucks for a test ride. You don't have to go for tooling. You can always go with this kind of manufacturing process. On the middle, what we have seen is basically a checking feature for your petrol tank lid, where we have done the design for that. On the left sides are the lock assemblies and all these other components which you have done it. And the video which is getting played now is basically a gripper for your what you call a gripper is used for a robotic arm. So, for example, if I have an aluminum aluminum gripper getting used, you can assume that always it will be an assembly of multiple parts, because machining of complex geometries will not be possible in CNC machine, and it will be an assembly fastened together, and for the performance also will depend on that. You need a lot of maintenance and all this kind of stuff. The gripper which is being played here is basically a single component designed and printed in 3D printer and works on a pneumatic structure, because as I told you, the HP parts are much more compared to any other technology. HP is the technology which gives you the airtight, watertight parts, so it can operate with the functionalities can be operated with a pneumatic or hydraulic one. So likewise, what we are speaking about is basically reducing the payload of your robotic arm, so that I can invest I have to invest for lower payload for the robot, so that the cost of my investment or implementation will be much more cheaper, and I will be able to have a completely integrated single unit getting printed as your end of the arm tool. So that is another lucrative market which you are speaking about. So when you overall look at this kind of implementation, what industry needs is basically a change in the approach, the way things are happening or things are getting organized in the industry. And the right people who can do this is basically the education system. Now, if you are spending time, if you are training people to do this kind of generative design using the current software tools available in ProE or CATIA or even Fusion 360s or whatever the design softwares you have, or specialized software like Alters or Materialize and all this kind of stuff, what we are able to do is basically change the approach of student who does the design. So this is something which is very critical for building up a generation which start thinking about digital manufacturing and optimization. The benefits are not only the economy of printing or economy of production, it also reduces the carbon imprints into the market, because I don't have to use this kind of equipments and to heavy material. I don't have to really do a lot of post processing and all this kind of stuff. So what it happens is basically faster turnaround, as well as for the environment, as well as for the person who lifts the parts and operates on an everyday basis. He is also will be less fatigue. So if you look at the manufacturing tools, whether it is a checking fixture, assembly fixture, or operational jigs. For example, if you are doing a painting in a paint shop of a car or automotive car manufacturer, what happens? You have to keep your door open for doing the painting. So there will be a jig which is be provided, which will be in aluminum. And over the aluminum, what they do, they will do some sort of coating of rubber-like material or glue some rubber-like material, so that scratches will not happen on the body. So likewise, they do a lot of this thing, and they will take a lot of pain in generating that jig itself. Here, it's a simple task: do an optimized design and use a plastic jig which is good enough for just keep the door open for painting. So likewise, when you walk across any factory, you can see over designs. You will see inconvenience in the production, mainly because of your current way of thinking and designing. So, for example, if you look at this end of the arm tool, it is completely driven using pneumatic, single print, single assembly, no assembly. It is basically a single unit, works the way you want it. So this is an innovative design which somebody has done it and printed in HP machine to get it implemented in a factory line. So similar is what we are speaking about when you speak about the designs and implementation of this kind of manufacturing tools. Now, if you look at any automotive company, if you look at, we have done a lot of activities in the automotive industry, because that is one of the predominant industry who uses 3D printing as a manufacturing this thing. And we have done a lot of jobs in the market for this kind of thing, including manifolds or external, internal parts, everything. Now, the key component which an educationalist or like you has to think about is basically optimizing the design for 3D printing. or they change the way you design it. For example, when I do an injection molding design, I always get into draft angles and all these components, which is required for designing a component for that. So if I go for a CNC machine, depending on the machine availability, meeting about this thing, I need to really think whether the tool changes, the tools are available, enough access is available, whether I can reach out. My part should not have any undercuts. So like this, I will be working with a lot of constraints. In this case, in a 3D printing, I can do a freeform design. I can do manufacture any complex geometry. I can insert lattice touches. For example, if you look at I want to make my equipment or a tool lightweight. What I can do is on the boundary or on the external surface, I can have a solid, and I can even think about a lattice structure inside so that the weight of the part will get come down. So likewise, I can do this kind of designing like topology optimization, part consolidation. I can speak about lattice structures. I can really consolidate all the parts and make it as a single assembly to get the functionality. Or one of the key important thing is design for packing. For example, if you are using a draft angle of injection molding, I may be able to fit 10 parts or manufacture 10 parts in the bucket what is available. But if I change the draft angle slightly, I will have a tighter packing, and number of parts which can get printed might be 20. So likewise, I can adjust the design in such a way that I will be able to enhance the packing and I can get maximum throughput from one print job. Likewise, I can just think about all these parameters when I decide that this part is going to get printed in 3D printing, and I need to design the job for 3D printing. For example, if you look at part consolidation, if this typical part which I have shown here, if I go for a injection molding, it will have minimum 10 parts. It will be an assembly of 10 parts, and you should have separate part numbers. You should have separate tools to manufacture that, and you have to really maintain the stock of all the 10 components for a long run. Here in this case, all these 10 parts are consolidated into a single unit, printed as a single part, and it carries a single part number for your design. And this is one of the components which is getting used in our HP 3D printers itself. On the right, if you look at, it is basically a component which HP uses in their production line to remove the sludges from your printhead manufacturing area. So the silicon sludges which comes out in the drilling process of a printhead. So what it does is basically it sucks out the silicon and just throws it away. So the initial design was a 575-gram aluminum part where it has got 8 components as fastened together, and every time the sludges will get accumulated in the path and there will be blockages. They have to do the cleaning, frequent cleaning and everything. What they have done is they have all the challenges in front of them. They designed a component to optimize the performance and optimize the design in such a way that it has become a 52-gram part, and this can be printed on demand. So when one this assembly is getting, or this part is getting nearing the breakage area, just at that point of time they can print the design and use that. So they don't have to stock this also. Similarly, the packing on the bottom, what I have shown you is basically a clip-like fastener which is getting used in your electronics market, where it's a cable type. So when we have printed that as in the original shape of a rectangle, the number of parts which can print it is almost 120, 130 in the bucket. But what I have done is I have given some living hinges for the design, and I have straightened it and started printing. The result was almost 500 parts can be printed from that. So when I do a small change in the design, my throughput is actually multiplying 5 times. So that is the way we will be able to really manage throughput by optimizing the packing. And on the right, I have shown you the lattice structures and the lattice structures which can get incorporated to reduce the weight. So these are tools are available in all your CAD softwares. When you have a design, you can do a design optimization using a CAD module like ProE or CATIA or any software you use it, or you can really do this lattice structures and all these things in the softwares available. So it is not something is available in the software. Even Autodesk NetFab has very specialized software for that. We have Magix, Materialize. Magix is also a very specialized software for this. We have Altairs. Altair has got a software for that. So likewise, there are multiple softwares in addition to the platforms what you have right now, like ProE or CATIA or anything. you will be able to really use the tools to optimize your design and make it in a much more economical way of manufacturing and improve this thing. So in conclusion, what we have to do is we have to really, if we want to achieve the digital manufacturing as a the successful implementation, first thing what you should have the right technology. Second thing is you have to choose the right application. And third and most important thing is you have to change your mindset the way you design your components. So if you are able to design your component in such a way that you will be able to enhance the performance as well as enhance the throughput, that is where your success of achieving higher capital efficiency can achieve through digital manufacturing. Now, for example, if you look at this is I'm just getting into some slides on the medical industry where if you look at on the left side, this is the normal orthopedic prosthetic hand where there is no functionality. It is just gives you that there is a hand this like this. But if you see on the right side, which is basically the first bionic hand developed by a Hyderabad company in association with us, where we had done we are the manufacturing partners for them, and they call this as Kalam mainly because this project has been initiated by Dr. Abdul Kalam, and on his advice only this project has started. And this is India's first bionic hand, which was launched last December, where it is a fully functional bionic hand with 18 gripping capabilities. So it is completely 3D printed because it is a personalized equipment for you. So if you look at any human being, every human body is different and everybody needs a different design. So personalization is the key here. It should be a personalized this thing. Or if we want to have standardization, I cannot do a standardization like an automotive or something like that. I can do a mass customization, like from an age group between this and this, there is one model. Size this, the size this. So some sort of mass customization can happen, but it cannot be a mass manufacturing. Then I can have, it always needs a short batch production. So this is one of the industry where 3D printers is going to be the most useful thing for them in the manufacturing arena. For example, if you look at functional prosthetics, on old days when I have my fracture in my wrist or something, what I have is a plaster of Paris cover where everybody will be putting their signatures. I will have a lot of itching and everything. Today, I can speak about a very generative design of this kind where you just clip it over there. When you're feeling uncomfortable, unclip, clean your hand and put it back. So likewise, if I can really work on prosthetics and orthosis, which is personalized for my hand, design is personalized for my hand, production is by 3D digital manufacturing, and I will be the functionality what I require, that is locking the movement of that hand, that is always can be achieved using this kind of orthosis and prosthetics. So it is completely a personalized equipment which you have to do it. Then anatomical models for surgery planning or education, or probably post-surgery safety gears. For example, if I have a surgery and I want to protect the movement or restrict the movement of certain areas in my body, or I need to have a protective gear put across, I can have a personalized equipment basically for that. For example, if I want, earlier days, our grandmother used to rub your head when they're giving you a bath every day and create the shape for your head. Today, we don't have time, we don't have the expertise to do that job. So people, what they're doing is, at different periods, they will keep printing the helmets, put it along with the for the kid every time, so that when he falls down, whatever happens, hits somewhere also, there is no injury happening for the head. At the same time, the head grows with a definite geometry or a shape. So these kind of applications are getting used in the industry today. Probably I spoke about the customized insoles. I can just go walk into a shop, scan my leg, get an insole printed for my leg, and fit into my shoe and start using it. Especially the sports people, to avoid injuries and everything, they extensively use this. So likewise, personalized items, this is the best way of manufacturing it. If you look at our experience in April, when the COVID broke down, when the PMO decided to go for ventilators all across, they have assigned a startup company called Aqua in Delhi to manufacture 10,000 ventilators. And we were manufacturing parts for them in the past because their manufacturing volume is almost 100, 200 ventilators in a month. And we were supporting them with the manufacturing of almost 12 components for every ventilator they launched in the market. So during this COVID time, we are assigned with the task of printing almost 1.2 lakh parts for 10,000 ventilators and deliver it in 25 days time. And we are able to achieve it mainly because we had these two machines of production machines of HP, which run 24/7. And with the human restrictions and operation restrictions because of lockdowns, we were able to achieve it mainly because the machine never broke down. We had a very seamless this thing, and we are able to manufacture all these 10,000 ventilator parts and supply it on time. Likewise, we have done the production day in and out. We are doing this production day in and out. We are doing this production of our machines, and we are quite experienced in various applications and uh, where it is getting used and which are the successful application, which is a failure application. So we are able to help you to choose the right application. We are able to help you with the right designs, modifications. We can suggest you what kind of design modifications you can do it. So all these things we are experienced, and that is what exactly we are speaking, or we are looking at from an education institute like VSSUT, where the professors can train their students how to design, how to do innovations in the design, how to get it manufactured using the digital manufacturing, and what are the changes we can bring in into the industry. Now, if you look at AICT curriculum also, I think there is a lot of stretch getting done on Industry 4 and its implementation, especially on these areas. And a lot of funds are getting provided to the education institutions to implement these labs and get the skill sets developed with the student community. So this is one of the areas where we would like to work with you. And if you look at HP also, being an HP premier partner for HP, we have all the solutions basically onto this segment, and we will be able to help you to really get it done. So what industry needs is multidisciplinary workforce, where today you cannot say that I don't know computers, because when you get employed somewhere, they might be using artificial intelligence for decision making. They might have IoTs embedded into their conventional manufacturing machines to transfer the data, and they may have the big data analytic tools, big data analytics implemented there with the raw automations and digital manufacturing. So mechatronics, electrical, mechanical, everything is fine, but today the skill set is required for with all these interface together, because end of the day, in a factory environment, people are looking at something like this. When COVID time came in, we had a good run because people started buying laptops, people started buying mobile phones, people started buying internet lines, they started storing data in cloud, they started sharing data from home. So the product, the design doesn't stop. Designers were working at home. The design job activities are happening. Production line was happening with the minimum people as per the government restrictions. And today we are able to implement it mainly because we have a complete network where we have the complete system ready for us to really have a cloud system. We have an analytics system. We have uh, people who sits at home, analyze the data, designers working at home, designs the data. There will be a minimum team working in the production line. So this is what is going to be the future tomorrow after the implementation of Industry 4, where cloud, IoTs, big data analytics, artificial intelligence, 3D printing, everything is going to get integrated together for your manufacturing environment. This is my last slide. So if you have any questions, we can take up the questions for the next 10-15 minutes. Thank you for giving me the opportunity here. And thank you for a patient listening from all of you. Thank you. Over to you, sir.
Okay, if you have any queries, you can go ahead. You can unmute yourself and ask. Participants, if you have any queries, please go ahead.
Yeah. Yeah. Completion ने मेल किया है एग्जाम एक्सटर्नल पैनल
I'm not able to get the question properly. So can you just tell me what was your question?
Else, you can put it in the chat box. You can put your queries in the chat box, so that will be convenient.
Yeah,
Sir, good evening, sir.
yeah, possibility and scope of fashion accessories. There is a question which somebody has asked for it. Almost, I think the fashion industry works on personalization, because if I spend some money and assign a fashion designer for designing something for me, I don't want anybody else to wear that. So basically, fashion industry, there is a lot of activities which we can do using 3D printed parts. Yeah, somebody was asking some question over the
Yeah,
phone.
sir, good evening. This is Kalicharan from the IT University.
Yeah,
Sir, am I audible to you, sir?
I am. You're audible. I'm able
Yeah,
to hear you.
sir. Actually, yeah, it's a good, nice presentations and so many things you discuss, sir. Actually, I am working with this IIoT at the present in connection with the computer integrated manufacturing system, sir. One thing I want to take a suggestion from you, sir. In case of your data communication from the particularly from design section to the manufacturing through the computer process planning.
Mm,
Okay, sir. Sir, generally we are spending the neutral file to them,
mm,
like your step file or IGS file or STL file. So generally, step file and STL file is easily accessed by these rapid prototyping machines. Okay, sir. But the thing is that in sometimes the machine is itself is showing some geometrical error.
mm,
That means the transformation of if you will put it through the some IoT system, that means data communication system. Okay, sir.
mm,
So data is not properly get transferred to the machine.
mm, mm.
So at that time, what precaution we can able to do that one,
Normally, so if you look at 3D printing, I think
sir?
we use a term called characterization. Characterization is nothing but, for example, the HP 3D printer itself, it can print 5 different materials. The melting
Sure.
temperature of these 5 different materials are different, right? If it is nylon PA12, it has got a
Sure.
melting temperature of 186 degrees. If it is with some glass build, glass 40% glass, the melting temperature goes up to almost 220. So what we know, and there is a different shrinkage factor for different materials. So what we normally do is when we are slicing it and when we start printing it, we will take up all the parameters of shrinkages, with the what do you call, the melting temperatures and everything, and we do something called we will in the machine, the firmware, we will give a module where the characterization of the material happens. So slicing and printing is not going to be a simple task, because we need to do a lot of optimization in your printing process when you are doing it.
Okay,
Okay.
sir. Point is here, sir. Sir, in case of this IoT system, main thing is that, sir, we are either making a common server or we are depending upon the cloud computing.
So
I
I
mean,
think
cloud system.
we are using a cloud system. HP machines today, what we are doing is the machines are directly connected to the cloud, and we
Sir,
do a lot of analysis and preventive maintenance and data analytics using that. So what we normally do is basically it provides me the complete health of the machine, because the machines are fitted with enough sensors, and it gives a
sir.
input to the cloud where this data is collected. So it is what we have in HP machines have got a inbuilt IoT devices built into the system itself.
Sir, sir, I also want to take one suggestion, sir. I am interested for this process total data communication system through this IoT. That means from
Yeah.
the suppose we are making a CAD model, in which manner this data is get stored and it can be again easily accessed from the cloud.
Okay. I
That
understand.
how can I can able to make
I'm
this one?
not the right guy for that. I think I'm more of a business sales guy
Okay,
with an
but
in-depth knowledge
nice
about
one,
the
sir. Nice
technology.
presentation.
Okay,
Nice
so what I will
technology,
do is
sir.
I will have the right guys introduced to you for getting this
Sir.
clarifications and get you the right link for that.
Sir. Okay, sir. I will. If you you have given the mail ID, etc., sir, I will be in touch with you and to know something more regarding this thing.
Sure, sure, sure. You're welcome.
Okay, sir. Thank you, sir.
Yeah. Any other questions?
If you have any queries, please go ahead. Otherwise, we'll conclude.
Okay, I think thanks all of you for being a part of this presentation, and thank you for the opportunity given to me. Thanks, Siti, for the introduction and really uh, moderating this discussion. Thank you very much.
So Jana said tomorrow there is online demo. So Tripti sir will be sending the link to us and we will take that
Yeah, fine.
session.
I think I'll try to set up a place where I will be using this Google and mobile camera to really show you the fine details of the machine. And I may also try to log in from another system where it will show you the overall this thing. I'll just set up something tomorrow morning. And what time is the this thing meeting, Vinod?
It is 10 o'clock tomorrow, sir. 10 o'clock
Okay.
tomorrow.
Yeah, fine. I'll try to set up some tomorrow morning something, and I will do it from the office tomorrow. Okay.
Okay.
Thank you, Binod, and thank you, Mr. Venkat, for an informative session here. And participants, Mr. Venkat will be joining us tomorrow as well, and there will be some virtual demonstration kind of thing. So let us join tomorrow at 10 o'clock, sharp by 10 o'clock. You can join 10 to 15 minutes prior to that in order to avoid any technical issues. So thank you, Vinod, and thank you, Mr. Venkat, once
Yeah,
again.
I will try to join. I think I might be driving that with our technical person Ravi Ranchan, who is along with Vinod may present it, and I will be a part of the presentation tomorrow also. Okay.
Thank you.
Okay, thank you. Thank you,
So,
Venkat.
so tomorrow link you will be sending or the same link will work, sir?
Same link. We will be using the same link that we have used today. So
Okay.
link is same. Timing is 10 o'clock in the morning.
Yeah, sure.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir. Thank you, participants. You can log out now. See you tomorrow at 10 o'clock. Please join 10 to 15 minutes prior to that. Thank you.
Thanks.